Start recording. Okay. We are on page 61. 61. 61. 61. 61. 61. Next week on Tuesday, so you are expected to memorize these, okay? But it's okay because I got your back. I will make it easy. I promise. We have a song. Okay. All right. So first of all, these are the metric prefixes. So for example, you might have megagrams or kilograms. And then I've left this blank here because there's just like regular grams or regular liters or regular seconds or whatever. These two here are both big. Okay, they're both big. And we're also going to learn what power of 10 they stand for. Okay? So mega stands for 10 to the 6. Kilo stands for 10 to the 3. And it makes sense that these are positive exponents because they are big. Okay, so we have positive exponents. So those are our two big ones. Mega is capital M. Kilo is lowercase k. So big M, little k. On the other side, we have all the small ones. These are all the ones that are smaller than 1. So we have negative exponents. And we have, they are deci, centi, milli, micro, and nano. And our powers of 10 are 10 to the negative 1, 10 to the negative 2, and 10 to the negative 3. That's pretty easy. Yes, 1, 2, 3. Negative 1, negative 2, negative 3. And then, just before we get over to those ones, I'd like you to notice that the difference between these two is 10 to the 3, which is 1,000. Okay, so a megaliter is 1,000 times bigger than a kiloliter. And mostly these prefixes go in thousands by 10 to the 3s. Okay, the only exceptions are the centi and the deci. Everything else is going to be to the power of a 6 or a 9 or a 12 or a 3. Okay, so we've got a 6 and a 3 here. Then we have 1, 2, 3. What do you think micro is going to be then? Negative 6. Okay, because you see that's another difference of 10 to the 3, right? Or actually 10 to the negative 3 here. And then nano would be 10 to the negative 9, because once again, we're getting smaller by 10 to the negative 3. Now, before we get too excited about singing any songs, we need to learn about this little micro thing here. Okay, micro. Let's go down to the bottom of the page here. If this is the line you are writing on, the first tail is a long tail. Okay. And the ending tail is a short tail. So how do you draw this? If this is the line you are writing on, you start below the line, you go up, and just like that. Okay? So if you were writing 10 microliters, it would look like this: 10 microliters, not 10 microliters. What's wrong with that one? Yeah. It looks more like an M, and it's going to get confusing, and it's up too high. Okay? It would be like if I was writing the word microliters, and all of a sudden the R was up high. You know what I mean? Right? Like we don't do that when we write. So we won't write this micro up there because it's, I guess a better example would be a P, right? P should be like that. P shouldn't be like that unless you want a capital P, right? Anyway. Okay. So those are our micro. And like I said, we do have a song. And the nice thing is, you already know the song, because do you remember? Liters, meters, moles, and Kelvin, kilograms, and seconds. Liters, meters, moles, and Kelvin, kilograms, and seconds. Okay, now, hold on for it. Mega, kilo, deci, centi, milli, micro, nano. And now we're going to do mega, kilo, deci, centi, milli, micro, nano. Everyone with me? Mega, kilo, deci, centi, milli, micro, nano. Mega, kilo, deci, centi, milli, micro, nano. Now, if you're like, hey, what happened to those powers of 10? How will I remember those? Well, we have a whole new line waiting for you in this wonderful, wonderful song. So, okay, we're going to do the first line, and then you're going to pause, and I'm going to sing the second line, and then we'll try the second line together. So we go, mega, kilo, deci, centi, milli, micro, nano. And now I'm just going to hang on this pitch for a little while, and I'm going to go 6, 3, 1, 2, 3, 6. Oh, you see 6, 3, 1, 2, 3, 6. And then 9 is for the nano. Okay, so we go meg, and then these are tens, of course. 10, 10, 10, 10, 10, 10, 10. These two are positive, and these ones are all negative. Okay, so once again, we're going to start from the top, okay? Mega, everyone with me? Kilo, deci, centi, milli, micro, nano. And now hang on this pitch. 6, 3, 1, 2, 3, 6. 9 is for the nano. Mega, kilo, deci, centi, milli, micro, nano. 6, 3, 1, 2, 3, 6. 9 is for the nano. One last time. Mega, kilo, deci, centi, milli, micro, nano. 6, 3, 1, 2, 3, 6. 9 is for the nano. Okay? We will sing this again tomorrow so that it sticks in your head forever. It'll be an earworm you can never get rid of. Imagine me having to sing it like every year, multiple times. It haunts me. That's okay. Did I tell you guys, was I telling you guys about Fernando? No? I have a student in my grade 9 class. His name is Fernando. And it's a wonderful name, but it always reminds me, there's a lovely, lovely ABBA song. Do you guys know ABBA? Okay. Lovely ABBA song called Fernando. Look it up, listen to it. It's a beautiful song. It's actually about the Spanish Civil War. So it's actually like a meaningful song. Beautiful song. But every time I see this kid's name in the book, I'm like, can you hear the drums, Fernando? Right? Anyway, so let's just let that go. Yes. Oh, positive, because my brain is not braining. Yes, thank you. The quiz tomorrow is on making measurements. Okay, so it will all be on 1.4D, 1.4E, 1.4F. And I'm going to hand back your using the burette that you did. I've just given you a completion mark for it. And if you see anything on there, like I'm like, oh, you need to write down what you're measuring, like if I've circled something that was missing, what you're going to do is you're going to take special note of that because you don't want to miss those things on your quiz. Yes? Okay. And part of today's work is going to be preparing for tomorrow's quiz. And I'm around tomorrow, flex and lunchtime if you have questions. Okay? All right. So that is that. And now we are going to move on to 1.5C on page 100. What a nice round number that is. All right. Up until this time, we have been looking at inexact numbers. These are things that inexact numbers are measurements. They are inexact because they have an uncertain digit. Page 100, 100. Exact numbers are not measurements. Okay, so one way that we might have an exact number, something that is not measured, is we might count it. Okay, so if I counted 4 eggs, and I'm like 1, 2, 3, 4, am I like, there's approximately 4 eggs? Or am I like, I exactly counted 4 eggs because I am a competent human being and I can count out the number of eggs? Yes? So that is an exact number. And it's not like I could have 4.3 eggs. Could I have 4.3 eggs? Not without breaking the eggs and mixing them up and doing all the thing. Okay, I cannot have 4 eggs with shells and everything. All right? If I say 8 molecules, let's say we had 8 water molecules. So that would be 1, 2, 3, 4, 5, 6, 7, 8 little Mickey Mouses. That is a small enough number of molecules that I could actually count those. So I would not mean approximately 8 molecules. I would mean exactly 8 molecules. Okay? So there's no uncertainty here. "17 elephants, 35 atoms, all of these are exact." Okay? And this is going to become important because exact numbers have to do with sig figs. And because, like, let's take the 4 eggs, for example. I could say that if I have 4 eggs, that would be the same as saying 4.0 eggs, yes? which would be the same as saying 4.00 eggs, or 4.000000 eggs. Yes? In fact, I could keep going all the way up to how many zeros? An infinite number of zeros. Yes? So how many sig figs are in that number? Any exact number has infinite sig figs. Okay, and do you guys know the symbol for infinity? It's the little sideways 8, okay? So we can say that we have infinite sig figs. That's just a nice way to shorten it, if you like, okay? So 17 elephants, that has infinite sig figs. 35 atoms, because that is exact, it has infinite sig figs. Now this works as long as we are dealing with a relatively small number of things that we could actually count, okay? Usually up to about 100 we could reasonably count as a human being. But what if I gave you 4.3 times 10 to the 6 atoms, right? If you remember, 4.3 times 10 to the 6, that is a positive number, so that's going to be big. So we're going to move our decimal place 1, 2, 3, 4, 5, 6 places, which means we're going to have 4300000. Do you think it is likely that if I give you that number that we have exactly 4,300,000 atoms, or do you think maybe we have plus or minus a few here and there?
Plus or minus.
Plus or minus, yes? So if I give you a number like that, you have to say this number has 2 sig figs and it is not counted one by one. 1 atom, 2 atoms, 300 million atoms, 400 million. No, okay? We're not counting that high. All right? And if it's not counted, it's going to be inexact. And it will have a specific number of sig figs. Is good? Okay. So here we have our specific numbers. Does it seem reasonable? We counted out exactly 4,300,000? No. And so the number is not exact, and therefore we have a reasonable number of sig figs. All right. So one way that something can be exact is if we count it. So if we count it, it is exact. Another way it can be exact is if we define it. So if we define two things as being equal to each other, then those numbers will also be exact. And if they are exact, then they have infinite sig figs. So let's look at a few examples of things that are defined. Now, the American measuring system You know, they still use feet and inches and pounds and all sorts of things. And we as Canadians sort of use those sometimes too, but they don't use metric hardly at all, okay? Not unless they're doing real science at the university level, and then they have to convert their whole brain into metric. So what they've done is we have defined, the scientific community has defined 1 inch, which is an imperial measurement. Okay, the imperial measurement is the American. And we have defined it as being exactly 2.54 centimeters. And of course, centimeters is not imperial, it is metric. And there is a physical constant, there is a physical thing that we use to say how much is a meter. I forget, it's how far light will travel in a vacuum in the space of however many seconds, but I can't remember what it is. Okay, but it's based on a physical thing that someone can actually go out and measure, and that is defined as a meter. Okay, and now they said, okay, well, we need the inch to be something compared to a standard, and so we'll compare it to the centimeter. Okay, now you are not expected to remember that this is an exact number. You're not expected to remember that this is an exact number. Anytime you are given this equality, 2.4 centimeters and 1 inch, you will be told that this 2.54 is exact. Yes? Therefore, if you're like, is that number exact? You'll be like, yes, it actually says the word exact. 1 inch, anytime you have a 1, it's always going to be exact. Okay, if you have a single 1 and you're looking at converting two things, right, that's always going to be exact. So this 1 has infinite sig figs, and this 2.54, even though it looks like it has 3 sig figs, because it is exact, it is infinite sig figs. I guess I could do a better job of circling that. Like I said, you would not be expected to know that that was exact, so it will always be written for you, but there are certain things you should know are exact. Are there approximately 60 seconds in 1 minute? Or are there exactly 60 seconds in 1 minute? Exactly, okay? So you should just know that these are exact. Are there approximately 24 hours in a day or exactly 24 hours in a day? Yes? Not all conversions are exact, but a lot of them are. Some of them you should just know. Like you should know that there's 60 seconds in 1 minute. And you're not like, ooh, I wonder if there could be 61 seconds in a minute. You're not going to be doing that, right? You're like, are there 25 hours in a day? Right? You'll know those are exact because you've lived your life in the world and, you know, stuff like that. Now, this next one, we have a metric unit and a metric unit. Anytime you go from metric to metric, those are going to be exact. Okay? There's not approximately 100 centimeters in a meter. We have defined a centimeter as being 1/100th of a meter. So there are exactly centimeters. So anytime you go from metric to metric, that's always exact. So the 100 is exact and the 1 is exact. There's a few other things that you should know, and this next one always gets me because people don't use much money anymore. So they pay with their card. And so many people don't actually know the symbol for cents. Do you guys know the symbol for cents? It's a little C with a line. And there are 100 cents in $1. Yes? Those are exact. There's not approximately 100. There's not like 99 cents in $1 or maybe 101. It's always exactly. Okay? And now we get into some other conversions. These are American volume measurements. So this is an imperial measurement, and this is an imperial measurement. And anytime you're going within a particular measurement system, that's always going to be exact. Just like metric to metric is exact, imperial to imperial is exact. So the 4 is exact, the 1 is exact. So this 4 has infinite sig figs, and this 1 has infinite sig figs. Milliliters and liters, those are both metric. So what does that tell you about the 1,000 and the 1? Are they exact or inexact? They are exact. Feet and yards are both imperial. And so are the 3 and the 1 exact or inexact? Inexact. Sorry, exact. I said it wrong. Sorry. All right. So anytime you're going between one measurement system, it's always exact. But if we go between imperial to metric, we're going to have, it's going to be inexact. At least for the decimal number. There's going to be one number that's just a 1. Okay? And then there's going to be a number that has a decimal in it. The 1 will be exact.
But from metric to imperial is exact.
No, either way. Either way. So if you go from imperial to metric or metric to imperial, those are exact. The number 1 is exact. And we're going to do a couple examples so that you can see what I mean by this, by decimal number. What is a decimal number and what is the 1 I'm referring to? So if we look at these guys down here, we have imperial. Okay, I'm going to put those all in blue. We've got blue and blue and blue. So yards and ounces and quarts are all imperial. Metric, we have meters and grams and liters, and those are all metric. So these ones, the decimal number is inexact. So that means that this one here is inexact. How many sig figs? 1, 2, 3, 4, 5 sig figs. This number that has a decimal in it is inexact. And it has 1, 2, 3, 4 sig figs. This number here has a decimal. It has 1, 2, 3, 4, 5 sig figs. These ones, on the other hand, all of those ones, one, those are all exact. So all of these have infinite sig figs. This is going to become important because in the next unit, we are going to be doing calculations with sig figs. And the result of, and if you've done physics, you already know this, the result of your calculation, if you're multiplying or dividing, you are limited in the number of sig figs by the smallest number in the question, in the calculation. So let's say we had 3 apples, and then somebody went out and measured a whole bunch of apples, and they figured out that the average mass of an apple is 4.3 grams. Okay, so it's 4.3 grams is how much one apple weighs. Yeah? And so then if I multiply this out, I get 3 times 4.3 will be 12.9. Thank you. I should have been able to do that in my head, but somehow I could not. 12.9 grams. Now, if I look at this, yeah? So if I do this, I've got the number 3, which has infinite sig figs, because I'm not like, do I have 3.5 apples? No, it's 3 apples, yes? And the 4.3 grams, that's per one average apple. That's an exact apple, okay? So this would also have infinite sig figs. And then this is an average value, so it has 2 sig figs. And when we do a calculation, our answer cannot have more sig figs than the smallest number in the question. Smallest number of sig figs in the question is 2. So I would have to take this answer and then round it to 2 sig figs, which would be 13. Don't worry about that for this unit, okay? But we will be doing that in our next unit, all right? Okay, so ones are always going to be exact. We also have some numbers over here. Do you remember this 1 mole is 6.02 times 10 to the 23? We talked about that. That's how many particles are in a mole. That number there is not exact. For one thing, it's a really big number. And for another thing, actually, let's pop to the next page. And we're going to skip down. This just says if you're converting within the imperial system, they're exact. Within the metric system, they are exact. Between imperial and metric are not exact, but there is one exception to that. And that is if I write for you, if I actually put the word exactly, then you have to believe me that that is exact. Okay, but other than that, if you have a decimal number, you'll be like, okay, normally that would have 3 sig figs unless I said exact. Per means out of exactly 1. So if I say 45 miles per hour, that's 45 miles in exactly 1 hour. Okay? So this 1 hour is exact, but that's a speed, 45 miles per hour. Did you have to measure a speed, or is that a counting thing? Do you guys know how to measure speed? Have you ever been in a car? Is that little doodad? What do they call it? The speedometer, the speedometer. Is that an exact number or a measured number? That is a measured number. Your car is measuring it for you, right? There's a little thing. There's going to be some uncertainty in that, all right? So the 45 is inexact, but the 1 hour is exact because anytime we say per, it just means per one exactly. So this would have 2 sig figs, so that would have 2 sig figs altogether. Same thing with a percent. Okay? 25.9% means that we have, sorry, per 100. Okay? So we have 29.5 out of exactly 100. So the 29.5 would have 3 sig figs, but the exactly 100 would have infinite sig figs because the 100 is exact. And now we're going to get down into what I was talking about before, the mole, the 6.02 times 10 to the 23. And those are on our next pages. For example, here we go. 6.02 times 10 to the 23 has 3 sig figs, because really, that's an approximation. This number actually goes on for much, much longer. This is the number we use in Chem 11. Chem 11 and 12. But if you were to have taken AP chemistry, where's my pen? Oh, it's plugged in. If you were to have taken AP Chem, they use this one. Right? It just means you have to punch more numbers into your calculator. Yes? Now, are either of those numbers exact? No, because you can actually calculate it to more decimal places, and it is exactly, this number here is exact. They have calculated it to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits. Are you ever going to use that number? No, because it is so big and awkward that who's going to ever remember that? It's like remembering pi to 10 digits. You know what I mean? Like some people like to do it just for fun, but yeah. So we're never going to have 6.02 be exact because we're not going to remember that many digits. 1 mole of a gas, that is 6.02 times 10 to the 23 gas molecules. At 0 degrees Celsius and 1 atmosphere takes up 22.4 liters of space. However, again, that 22.4 is not exact because somebody had to measure that volume. Somebody had to say, what is the volume? And they had to like take a container and measure it and things like that. And they did measure things, and they've done some calculations that allowed them to figure out it is exactly that, but that has now been rounded off to 3 digits. So this would have 3 sig figs. Okay. Now, we have some exercises here, which you can, oh, sorry, yes. There we go. We have some exercises here which you can work on. If you would prefer to go and finish the quad beam balance first, you can do that because you have the quad beam balances here. All right, and you can prepare for tomorrow's quiz. So if you want to do these ones first and then leave that for later, that would be fine by me. All right, because we only have a half an hour and I'd like to give you some time to work on these because they will help prepare you for tomorrow's quiz. Yes. I'll come back. Okay, cool. You'll get your quizzes back as soon as I have them up. I will get you back.
I have a couple of
Yeah, we do scale, okay.
Well, if you're gonna use 6.022140867.
So you were
Okay, so 1 year is not 365 days, that is impression.
Yeah.
Because, yeah, but all the other ones, all like 7 days to wait, that's not. Oh. That's.
I thought, why don't you bring out your calculator?
What? I did it. Most look smart. No, most look smart. You didn't choose.
Exactly.
You know what, like,
It's okay, it's okay.
Okay, let's get you guys.
Babe, we need a scale, right? Am I right? For page 19, this is the scale. For page 19.
For page 19, you need to skip, yes.
yeah.
Right there.
Oh, those scales?
Yes.
Okay.
Oh, you need an electronic one. Those are at the back of the classroom in the corner there. Someone have to measure it.
Everything has.
Well, I don't have to measure 10 fingers, I just count. 3, 4, 5, 6, 7, 8, 9, 10. Counting is different from measuring.
So,
Counting is exact and measuring is.
do we have anywhere to plug? Oh, we do.
I don't have 10.
That's the same thing for the thing.
I'm just on
They wouldn't help. Wait.
Each goes in there.
I said my age.
No, mine goes there.
Well, it's loud, you're getting back. Just completion marks, okay, so we're gonna 10 out of 10. Cause I already kind of looked like I'm sure. Okay.
We're technically actually.
Why?
Because I was.
Started whatever you want. Okay, that's fair.
Yeah. I don't know, I didn't.
They have 15 pins get off, 15 pins stay on. 15 get off, 15 stay on.
Any comes to that, be careful.
I did get it.
Yeah.
I thought you didn't.
It's like shit.
Learn the words now. What was that? All right. You must. Like,
But when I said it, you take the.
Last year.
Okay, confidence.
You know.
Yeah.
Well, I remember last year you said no, keep it.
Oh, yeah, so we brought pen and I'll write with you.
No, he's not.
Huh?
What do you mean? Oh, okay.
So what was it?
I had been from answered.
Oh, okay, yes. Okay, so let's get a deeper for you.
Oh, and I'm just spoken.
Okay, I get this. And so that's really weird. Why are you crossing?
I crossed my legs.
Yeah, that's like the finger cross, then there's the come get me cross.
Why do you know all this stuff?
Here's the thing, right?
All right,
What does that mean? Of course I know what you say.
Stop talking. Stop.
He has a PhD.
He's a young kid.
Scale. Scale? A scale?
Okay, so eight is too much. So then.
This scale?
What is this like?
500, 5,000.
There's a lot of downs.
Electric scale.
Yeah, that's why I close down once again. Fine, okay. So what we have.
Electronic scale. Electronic. You just said it.
I have more than
Yeah. What's the name of this?
Listen, 0.8.
Let's see what's
Banana.
Six.
What is that?
That is I meant eight.
Yeah. Concrete block. Only if there's something how to make it. There's no use. How did you? Let's go with that. What's the ball?
Yeah.
Pull, concrete, ball. No doors, no.
Read the red light.
Concrete ball. And then it's one people. How does he get it? No door.
How do you get it?
Sure.
No window.
How do you get it?
That's not important to me. Repeat that. You said he got into the door.
He's in a ball.
How they get us these things on the boss was
I feel like he's pointing at the
That's not important. Alright, so he's in a box, so you know when you have how to get out.
Like really.
Smash that table against the wall.
Wait, no, what's the answer?
You should have to get that. That's the dumbest thing I've ever heard. That's terrible.
Yeah, I saw the table.
Hey folks, listen for your name. I'm giving back your quizzes.
It's on the table.
Yeonju,
He says two half, like a hole. You already have a whole table.
In the box.
Crawl
out of the hole, out of the box.
That's the dumbest.
Evan, Jofi, Charanyu, Taram, Yeonju, Celia, Bahar, Caitlin,
There you go.
Charanyu,
Boom.
Jofi,
Not a mother.
Did I miss it? I'm a.
Robbie,
I'm really motivated.
Beta,
It was gonna move, but it's supposed to.
That's why I'm asking.
which one did you want to redo? The first one. Gotcha. I'll grab you one of those right this second.
Why does our scale know what is it?
Ah, that's because that's the uncertain digit.
Well, it's like it's down 7, 9. If I was not the part that
My brain.
There's a 9 F one though. 9 F, F, I was in mind. 9.
Okay, Chelsea, Owen, Matthew. Chelsea, Owen, Matthew, Lasya. You grab Lasya's for her?
Just because I'm such a nice girl.
Yeah.
Matthew, let's go.
Tanya, Brandon, Charlotte. Hang on. That's Brandon's. Charlotte, there we go. Evan, Sunbed. Gustavo, Kasumi,
Which is more precise.
Noah, Youngwook,
I am not required to sell energy.
Yes, Lord.
Yuna, Rico.
Right, stop.
There you go.
Oh,
Greta,
So imagine like that. So imagine that if we did like that.
do you want to do it now? Do you want to do it now? Okay. Yes.
If I retake it, is it going to be the same?
Huh? No, it'll be different numbers, obviously.
I do a quick quiz.
Sure.
That's the one. Quick quiz in 1996. Great.
If anyone wants to redo a quiz right now, you can redo a quiz right now. Let me know.
Failing baking is the craziest thing I've ever heard.
Hi.
understand it now.
You get it now?
Oh, yeah.
So you want to redo? Okay, cool.
Can I redo?
Yes. So you guys all want version B, yeah? Okay, let me find this one. Fix B. There we are.
So it's okay. I get it.
You
0,
can just keep
click
that on a
S to D.
One for you. Just make sure you like put up a divide
Yeah.
or something or same part.
Thank you.
Okay?
Do I have to give you this?
No, you can. Hello. Yes, very good. Thank you very much. Quiz, yes. So sorry. There we go. Yes.
Why is it so hard?
There you go. So sorry.
Congratulations.
If you re-quiz. Oh, yeah, yeah. So you want to redo it? Yeah. You can get 24. Let me see, we're gonna put those ones. I put that right here. Well, there you go.
I went 2 meters away and I can still hear you. What do we do now? What is 19 to 96? Is it
In your
1.4?
book, I think this is.
Oh, we do the whole pages or like just 1.4 to 6?
These are sections.
Oh,
Yeah, sure.
Okay, guys, it's coming out later.
You should know the quadruple beam balance. Quad beam balance. Yeah. Let me just take a check and see what I've actually got on here.
Like, can I apologize?
Measuring, there we are. You should know the quad beam balance, a ruler, a burette. That's the one we did yesterday. Do you remember this one? Yeah? And that's it. Yeah. All the rest of them.
Yeah, no, because I thought it was a reasonable time. So I'm gonna pass the first one too. My calculator was.
Yeah. This one? Yes.
Right there.
I would have gone to pre-work.
Not now, later. Perfect.
So your name sounds.
I didn't know that.
Oh, you remember the website? Open, where are you? Is it? Oh, it's here. Are you talking?
No, you put it in that little box.
Yes.
This is teaching you how to English.
Oh, I've gotten Mr. 5. Yeah, I just.
Yeah.
You like she was saying. Well, let's just say the kid kind of has God.
Yeah. Do you know what you did wrong? Okay, perfect. Counting 6 spoon. Are we on? Right. All right, that looks good. You're just missing something there.
The unit?
The unit. Okay. Yeah, I'll sign it for you and then yeah. There you go. Okay. Hi, Matthew. Actually, can I get you to go sit at your desk and do this? Yeah, there you go. Thank you. All right. Now, the smallest division is 0.01, so you can estimate to 0.001, but you only have to 0.01. Oh, and you're missing something at the end.
All right, guys. I should tell you this whole. You guys are gonna.
Yeah, and actually what I'm gonna do is I'm gonna give you a copy of this one, all right? Because this is exactly what it's going to look like, all right? And it is on page.
Oh, I get it. I get
You know how excited like.
That's on page 61. That's it. Okay, and if you want to practice, there's some practice with little things, and then there's a blank one as well. So this is all, yeah, 61. Okay? Yeah. We'll just put that in there for now because I've actually got a whole bunch. Okay, I'll get that back to you soon. Okay, that looks much better. That's a terrible signature. Oh well, that's okay. Yeah.
That's yesterday. But that's just.
You can do all of it. I think yesterday we did this.
Oh, they're not finished.
This is the last sig fix. This is the answer thing for that.
This is the last sig. 1, 2, 3 sig fix. Right. Yes.
What is that?
Oh, that would be like plus or minus.
Oh,
Yeah.
okay.
Yeah. And that's totally optional.
Okay.
Yeah.
Thank you. Also, how do you check if I did the enriched stuff?
I give you the quiz, and if you do it on the quiz, then I say, oh, you got enriched credit.
Okay.
Yeah.
Wait, does it say like do enriched?
Oh, let me see. Did I put that on here? I might just give it to you as an option, and I might have to remind you. Where did I go?
Sorry, what?
No, but you can just include it. I'll try and put a note on the board to remind
Okay.
people if they want to.
Is it
Yeah.
none of the last ones we had any good stuff?
None of the which?
The last
No,
quizzes?
none of
No? Okay, perfect. Thank you.
Hi.
Can I just go to my locker if we can get my time?
Yes.
Like, wait.
Believe it.
Thank you.
Like, move it around. Like.
That's not external.
Yes.
Like, you know, general, the asset thing.
You're 100% of the time.
What?
So walking up.
How do you say like mine is just like stop.
The time.
Thank you. I'll give you that one back. You just have it.
What situation?
You just got off the happens.
Hey, Owen.
How are you today? Oh, we're all doing very well. I'll worry about it. You got 4 to 12 minutes.
It's okay, right? I understand. I can like broadcast program these things.
Yeah. You got it now? Okay.
Actually, it's never yes, maybe.
Okay, that looks good. And did you notice how that number kept flipping around a little bit?
Yeah.
That is because that is your uncertain digit. What did I do with my pen? There's my pen.
They're doing like experiments.
There we go.
I have to stop.
Yes, you want to redo? There you go.
If you don't know the name of the tools.
You need to know ruler, you need to know quad beam balance, and you need to know burette. Because those are the three that you have used in your life, okay? Folks,
Can you read it? No?
yeah,
I don't know this problem.
actually burette is, I won't make you know burette. You can know burette if you want to. Okay?
Some random thing, like, studying. I'm studying like this, and I'm like, actually. How's your foot?
The first one, yes, your sample, so it would have been on, oh, this one, okay, yes. So this one is page 61.
The ruler.
Maybe not tomorrow because you've got another quiz class. Or if you want to do it tomorrow, yeah, it's fine. Okay, if you feel ready for both. Yeah, and like if you're supposed to 61, like there's practice and there's practice. It's just after that same table. It's just practice. And this one has some of the things in it, and then this one has none of the things. So this is exactly right. Yes.
Yeah, if you want that one. I'm gonna need to do it.
There you go.
It was like books combined with those books. Guys, I was like, those books.
Okay, I'm not sure, but okay.
Yes. Yeah. Do you understand where you went wrong?
For some of them, yeah.
Yeah. Okay. So how about this one?
Yeah.
Do you know why that one is not your uncertain digit? Exactly. Well, this is this is certain, this one is uncertain. Yeah, perfect. Same thing here. Okay, that's your uncertain digit. And then we have, what were the other ones? Oh yeah, you just didn't circle them here.
Yeah, for these ones, yeah.
Yeah, anyway, just circle them. Okay, and then this one, how did you get 3?
I was thinking these three that was the ones that were.
Okay, so these zeros are in between.
And then, but yeah.
And then this has a decimal, so that one is significant. So ones on the right are significant if there is a decimal. Yeah? Yeah. And then this one, zeros on the left are never significant. Okay? That 0 on the right is significant because there is a decimal. Okay?
Okay.
Yeah. Cool.
Is it okay if I come in for flights tomorrow?
Perfect. Yeah, let's do that.
Okay.
Okay?
Thank you.
Yeah.
Do we need to remember the measuring device?
You should know these 3 measuring devices because you've used them. You should know the ruler, the quad beam balance, and the burette. Other than that, I don't care.
Thank you.
Yes. Thank you. All right, lovelies, thank you for working hard. Have a wonderful evening. I will see you tomorrow. Okay.
Got my pencil.
We see Amy's face. She's
No.
smiling. She doesn't have. Why is she smiling?
Bye.
My hands are turning.
Yeah, take pictures for sure.
Why is she so desperate to get rid of it?
So we just try to plug in.
Yeah, you don't have to like quadruple if you don't want to. Quad is good enough. Joe. Like 7. Okay. Song. About 8. 8. Okay. 7. Thank you. Pardon me? Yes. You can do better. Yes. Okay. Hello. Oh, in the beginning of class, we went over. It's recorded.
Yeah. I was about to check, but then like just to make sure.
Yes. We went over. Were you here for the exact and inexact numbers?